Welcome back. Get our screen sharing going here. So we are continuing with the free response questions on Form B, question 4. I picked this one specifically because I've noticed a pattern in some of the work that one of you have been submitting with finding the critical points. So I really want to focus on this first objective, determining candidates for critical points. Namely, we just need to test the start point and end point every time that we test our critical points as well. We'll also be solving for constants of a composite function involving displacement, velocity, and acceleration of a particle given its position. Okay, if you haven't already, I did post those two questions to the AP Classroom site, which is available here at myap.collegeboard.org. You shouldn't need your section code in order to do it, but just in case, I've got your section code here and all the PowerPoints this week too. So for today, so we've got this particle that's moving with this position given by its position at any time is equal to e to the negative t sine t for 0 to 2 pi. I want to find the time t where the particle is the furthest to the left. What do I have to do first?
Drive and
Okay, derive and what?
pick the point where is negative.
Okay, I'm going to derive this first. Let's do that. So I've got a position function. I'm going to get a function for velocity by deriving this. So x prime at t equals vt is equal to what? What happens when I derive this?
E to the negative t power over t.
So this is product rule. If I derive e to the x, I get e to the x dx. So if I derive e to the negative t, what will I get?
Cosine t.
Okay, I've got e to the negative t cosine t plus product rule. When I derive e to the negative t, what's going to happen?
E to the negative t over t.
Not over t, no. So this is e to the x dx. What's my derivative of the power right now? If I derive e to the x, I get e to the x times dx with chain rule, right? So if I was to derive e to the 3x, I would get 3e to the 3x. If I derive e to the negative
Hello?
t, what do I get? Hello?
Oh, now it's working. Okay, great. Sorry.
That's okay. So what should this be?
Negative e.
Negative e to the...
Negative t.
Negative t power. Okay, there we go. So that was product rule. I had two functions, e to the negative t and sine t, so that's f and g. If I derive it, I'll get f prime g plus fg prime. Okay, now this is my function for velocity. If I want my particle to move as far to the left as possible, and that means we need to know when the particle changes direction. In order to change direction, our velocity must be equal to 0. So I'm going to set this equal to 0, and we'll solve for times. 0 is equal to e to the negative t cosine t plus negative e to the negative t. I'm just going to make that a negative, so minus e to the negative t sine t. And therefore, I could pull out my e to the negative t, and this would be e to the negative t times cosine t minus sine t is equal to 0. Okay, so this will be equal to 0 whenever cosine minus sine is equal to 0, since e to the negative t can never equal 0, right? If I raise something to a power of 0, it would be 1. If I raise something to a negative power, it'll be 1 over something. If I raise something to a positive power, it'll be a really big number. So because this part can never equal 0, we just need to set this part equal to 0. So I've got 0 equals the cosine of t minus the sine of t, or the sine of t equals the cosine of t whenever this is true. Okay, so for what angles on the unit circle is the sine equal to the cosine? Oliver.
Hello?
Hello. I want to know what angles on the unit circle is the sine equal to the cosine?
At 0 and pi.
At
And
0,
pi half.
at 0, sine is 0, but the cosine is 1, so the sine does not equal the cosine.
Oh, at pi root of 2 over 2.
Root 2 over 2 is going to be the magnitude of the side, but what's the angle where that's true?
60. 45.
45, which is pi over 4 in radians. Okay, then I've got one more. So we said this is 45, where both of our side lengths are root 2 over 2. So the sine is equal to the cosine. Also this angle down here, where both of our side lengths are negative root 2 over 2. So what angle would this one be?
This would be eins, zwei, drei, vier, 6 pi 8 over 8.
6 pi over 8 would be 3 pi fourths, would be up
5 pi.
here. Okay, so 5 pi fourths.
Oh no. 5
5 pi fourths. I'm going to draw out my unit circle one more time, I think. It's been a while. So I'm going to start with all of my pi fourths, since that's what we were looking for here. So I'm going to draw 1 pi, which is a semicircle. If I split this up into fourths, then I can split it in half, and then in half again. So this is pi fourths, 2 pi fourths, which is pi halves, 3 pi fourths, and 4 pi fourths, which is pi. At any odd number times pi fourths, our side lengths are equal. So at pi fourths, the magnitude is root 2 over 2. If I kept going for one more pi fourths, so out here. This would be 5 pi fourths, 3 pi over 2. That's 6 pi fourths, 7 pi fourths, and 8 pi fourths, which is 2 pi. If I split this up into sixths instead, so here's my half circle again. If I split this up into sixths, then what I can do is I can split each half into 3 equal parts. So something like this, where this would be 1 pi 6, 2 pi 6, which is pi thirds, 3 pi 6 is pi halves, 4 pi 6 is 2 pi thirds, 5 pi 6, which does not reduce, and then 6 pi 6, which is pi. For each one of these, if I drop a line to the axis, I will end up having a long side and a short side. So for pi 6, this is a long side and this is a short side. Your long side is always root 3 over 2. And your short side is always 1/2. Your equal sides, which only happen at odd number times pi fourths, are magnitudes of root 2 over 2. Okay, any questions on the unit circle?
No.
Okay, I'm going to erase our unit circle really quick, which I can do a little bit faster if I end this, I think. There we go. Okay, so we said this is true when t is pi fourths or 5 pi fourths. So if I'm looking for when the particle is furthest to the left, that's when this position function is an absolute minimum. So as small as possible. Then I need to test my critical points, which are pi fourths and 5 pi fourths, but I also need to test what? Junho. So
0.
0 and
2 pi.
0 and 2 pi, perfect. So we've got 0, pi fourths, our first critical point, 5 pi fourths, my second critical point, and 2 pi, our end point. For absolute minimums and maximums, we will always need to test the start point and the end point of our interval. Because it's possible for our function to do something like this, where I had a relative minimum, relative maximum, relative minimum for our critical points. But my highest point on this interval was actually the start point. Because the start point and end points can always be the highest value or lowest value, we'll need to test them when we test for our absolute minimum or maximum. Okay, so I'm going to plug these into our x of t function, which is here. So this is e to the negative 0 power times the sign at 0. What is e to the negative 0 power?
1.
1. What is the sign of 0?
Sine of 0.
0. So this is 1 times 0 is 0. Okay, then I've got e to the negative pi fourths times the sign at pi fourths. What is the sign at pi fourths?
Root 2 over 2.
Root 2 over 2. So this is going to be 1 over e to the pi fourths times root 2 over 2, which I'm going to leave like that for now. Okay, my next value is going to be e to the 5 pi fourths. Oop, I'm sorry. That was positive pi fourths, not negative pi fourths. This will be e to the pi fourths. Easier than I had it. Okay, e to the 5 pi fourths times the sine at 5 pi fourths. What's the sine at 5 pi fourths?
Negative root 2 over 2.
Negative root 2 over 2. Okay, so far I've got 0, a positive value, and a negative value. And if I plug in 2 pi, this will be e to the 2 pi times the sine at 2 pi. Or e to the 2 pi times what? What is the sine at 2 pi?
Uh,
1.
0.
0. So at 2 pi, that's 0. My cosine is my adjacent, so if I was going to draw a triangle here, I have a side length of 0 here for my y value. My x value is all of our radius, which is 1. Cosine is always x, sine is always y. Okay, so that gives me 0, a negative number, and a positive number, and 0. So which one is our furthest left? At what time are we the furthest left?
Mm,
5 pi over
5
4.
pi.
Perfect. So a little bit out of space here, so I'm going to write over here, I guess. The particle is farthest to the left when t equals 5 pi over 4. Any questions on how we did that? Okay, the key here, what I really want to stress for this one, is that we have to test our start point and end points when we're testing for absolute minimum or maximum. So if we want to know when a thrown object is at its highest point or lowest point, we'll need to test the absolute minimum and maximum as well as any critical points. Okay, I'm going to keep going with this. So for part B, I want to find the value for the constant a that satisfies this differential equation. A times x prime prime of t plus x prime t plus x of t equals 0 for 0 to 2 pi. Okay, so the first thing I'm going to do is, since we already know what x prime at t is from last time, I'm going to use that to solve for x prime prime at t. So let me write all three of these down. We were given this. X of t is equal to e to the negative t sine t. And then we solved last time for x prime t, saying x prime of t was equal to this. So that was e to the negative t times the cosine of t minus the sine of t. So if I derive this one more time to get the second derivative, what will happen?
E to negative t times negative sine t plus cosine t.
If I derive sine, I get cosine. So if I derive negative sine, I should get
Negative cosine.
negative cosine. Okay, and then product rule. So plus what?
negative e to the negative t power cosine t minus sine.
Perfect. Okay. So we can simplify this a little bit. I could factor out my e to the negative t's again. And that would leave me with this. X prime prime of t is equal to e to the negative t times negative sine t minus cosine t minus cosine t minus sine t, which if you'll notice we can combine these. Negative cosine minus cosine is negative 2 cosine, and negative sine plus sine should cancel, right? So this will become e to the negative t times negative 2 cosine t, or negative 2 e to the negative t cosine t. Any questions on what we did there?
No.
No.
Okay, so now all we need to do is plug this into our differential equation and solve for a. So I'm going to start that here, and I'll probably have to move to another slide. So this is a times x prime prime t, or a times negative 2 e to the negative t cosine t. I'm going to break this apart because that looks like I combined the t there. There we go. Plus e to the negative t times, I did it again, e to the negative t, there we go, times cosine t minus sine t, plus e to the negative t sine t is equal to 0. Okay, and we'll need to solve for a. I'm going to keep this last line. And we'll keep going from there. Okay, so from here, I've got an e to the negative t in every term. So I'm going to factor that out and then divide by e to the negative t on both sides, which will cancel. So that'll leave me with negative 2a cosine t plus cosine t minus sine t plus sine t is equal to 0. If I divide both sides by e to the negative t right now, that would divide every term by e to the negative t, which would cancel this one, and this one.
Okay.
Okay, so I can combine these now. So I've got the negative sine t and the positive sine t will cancel. So that leaves me with negative 2a cosine t plus cosine t equals 0. I can factor out my cosine t now, so do the same thing that I did for the a's. If I pull this out and divide by cosine t, then I'll be left with negative 2a plus 1 equals 0. Divided everything by cosine t. 0 divided by cosine is 0. Cosine divided by cosine is 1. Negative 2a cosine t divided by cosine t is negative 2a. And then solve for a. So I've got 1 equals 2a, or a equals 1/2. Any questions on what we did?
No.
Okay. I'm going to take a look at the scoring guide really quick. Okay, so scoring guide. For part A, we've got 2 points for x prime at t. Okay, so we got that for our derivative. Setting it equal to 0 to get our critical points. Okay, getting your answer, which is particles furthest to the left at 5 pi over 4, and then justification. To get that justification, we need to test 0, pi fourths, 5 pi fourths, and 2 pi, which we did. Okay, 2 points for the second derivative of t. Negative 2e to the negative t cosine t, which we did. Substituting the second, first, and regular function into our equation, which we did, and then getting our answer of 1/2. Okay, that all looks good, so this should be 9 out of 9. Crop this for later. Okay, so if there are no more questions, please make sure that you log into the AP Classroom and finish the 2 problems that we have there. And I will post the annotations for this for your response up to the WeChat. The homework for today is the question 5 and 6 from the 2007. So last time you had questions
Okay.
1, 3, I believe. All right, thank you very much, and I will see you on Friday. Goodbye.
Bye.
Bye.